Okay, we're looking at mini test week 27 and question 1. So we've got two particles. We're given the mass of particle P, and we're going to have to find the mass of particle Q. And the first thing you always want to do is just sketch out what they're describing. So they're connected by a light inextensible string. They're on a smooth horizontal plane. And we've got a horizontal force applied to Q in a direction away from P, and we know what the acceleration is. Okay, so drawing should look something like that. There's a few things I need to add on. I'm going to label up the reaction forces. They're not actually going to be relevant for this question, but it certainly doesn't hurt to have them there. And then I've got tension in the string. Okay, so because the string is inextensible, when it starts moving, when the body starts moving at 2.5 meters a second squared, oh, hang on, sorry, I need to get rid of that. Sorry, and that's wrong, isn't it? That should be 2.5 meters a second squared. So they're both going to move with the same acceleration because the string is inextensible, and because the string is light, the tension is going to be the same. So the tension that is pulling along particle P will be the same as the tension that is sort of pulling back on particle Q. So to find M, I'm going to model the whole thing as one body. So I'm going to combine both of them. So imagine that's them combined. So I've got the 40 Newton force working that way. I've got a total mass of, it's not going to fit in my box, is it? But 10 plus M kilograms. So the weight is 10 plus mg. And again, I've got a reaction force that I'm not going to need to use in my calculations. So if I use F equals ma, and it's moving to the right, so I'll take that as positive. So the only force is the 40 newtons, and that equals the mass, which is 10 plus m, if I'm doing the whole thing combined. And then the acceleration I was told in the question is 2.5. So if I do 40 divided by 2.5, I get 60. And if I take 10 away, I get m is 6 kilograms. Okay, so that's my answer to part A. So B, find the tension in the string. Right, so for this, I can look at either particle P or particle Q. I'm going to look at particle P because I was given all the values for P. So if I have made a mistake and M isn't 6, this isn't going to affect my answer to P. And also P has less forces on it. So Q has the 40 newtons and tension. P just has the tension pulling it along. So if I just look at particle P, so P is being pulled along by the tension in the string, which is what I'm trying to find. It's got a mass of 10 kilograms, so a weight of 10 g, and a reaction force. So if I use F equals ma, and again, we'll take right as positive because it's moving to the right. So the only force on particle P, so this is particle P I'm sketching here, is the tension, and that equals its mass, which is 10 kilograms, times acceleration, which is 2.5, so tension is 25 newtons. Now, if you wanted, if you were in an exam, you want to just sort of double check your answer, if we look at particle Q, we should get the same answer. So particle Q had the 40 newtons pulling it along. We think, hopefully, if my mass was correct, that the mass of particle Q is 6 kilograms. So this is the force diagram for Q. So I use F equals ma, taking right as positive on particle Q. The resultant force is 40 to the right, take away the tension, which equals the mass of 6 times the acceleration of 2.5. So that would give me 40 minus t is that 15? Yep, 15. So if I add t over to the right-hand side, subtract the 15 from the left-hand side, that's always good. We get the same answer.